Hi, this is the PowerPoint presentation for Chapter 6 of Real Estate Investment and Finance. In this chapter, we'll be talking about residential financial analysis. The objectives in this chapter are a lot of basically different types of problems. We'll look at calculating the incremental cost of borrowing, so borrowing an additional amount. Evaluate the effects of prepayment penalties, origination fees, and other charges on this incremental borrowing. Discuss the decision to refinance. How would we make that decision? Calculate the market value of an outstanding loan, mortgage loan, and then talk about below market financing and effects on the sales price. Okay, first we'll discuss incremental borrowing. So what we're talking about here is evaluating two loan alternatives, where one alternative involves borrowing an additional funds relative to another. So following along with the example in the book here, they have alternative one that's an $80,000, so it's looking at a house, $100,000 house. Alternative one is an $80,000 loan, where alternative two is a $90,000 loan. The alternative one, $80,000 loan, has a 12% rate, where the alternative two, the $90,000 loan, has a 13% rate. So the key thing here is the important cost we're looking at, even though we know those effective rates, is the incremental cost of acquiring or borrowing that extra $10,000, going from the $80,000 to $10,000. So either putting down a $100,000 house, putting down $10,000, borrowing $90,000, or putting down $20,000 and borrowing $80,000. What's the cost of borrowing that extra $10,000? Okay, so looking at what the payments would be with alternative two, the $90,000 at 13%, and these are all 25-year loans. They'll calculate the payment is $1,015.05. Where alternative two, the 12% loan, 25 years again, $80,000. The payment would be $842.58. So the difference in the loan amount is $10,000, and the difference in the payment between these two loans are $172.47. So now we'd want to say, okay, so what's the cost of that borrowing that extra $10,000? Well, N is 300 because it's 25 years times the 12 months a year. The extra amount, or the amount we're borrowing, is $10,000. That in as a negative. The payment, the extra amount we have to pay because of borrowing that $10,000 is $172.47. It's fully amortizing, so the future value would be 0. And we compute the interest rate. Okay, again, we're going to get a monthly, multiply it times 12, and we see that rate is 20.57%. So that's the incremental cost of borrowing. So in other words, if you had the $10,000 to put down, that would be what you're assuming there. You had the $10,000 to put down. You'd say, well, should I put the $10,000 down, or can I invest it somewhere for more than? Can I invest it somewhere basically for less than? I did 20%, 20.57%. Okay, the weighted average cost of this would be the $80,000 at the 80,000 divided by the 90 at the 12%, and then the extra 100 at the 90 at the 20.57%, which would give us the almost 13 or 12.95 as a weighted average. So in conclusion, if you have the $10,000 available and you can invest it somewhere for more than the 20%, 20.6%, let's just round, elsewhere, then you should borrow the $90,000, okay? Otherwise, you should only borrow $80,000 and put the other $10,000 down, okay? So, getting over almost a 21% return is pretty tough. So, if you have that $10,000, you can't invest it for 21% anywhere else, then you should, borrow the $80,000 and put the other $10,000 down. Okay, because basically you'll be getting a almost 21% return. Okay, if you don't have the $10,000, okay, and you can't borrow it for anywhere else for less than the 20.6%, then you need to borrow the $90,000. Otherwise, you should borrow the $80,000 and then borrow the $10,000 somewhere else where you could get it for less than 20.57. Okay, so that's what we're going to find, is that this idea of the second mortgage has to be at a competitive rate. If we can find out what the incremental cost of borrowing is, the second should be at about that amount. Otherwise, people would go out if the second was for much less. If you could get a second mortgage, a $10,000 second mortgage for, even 15% here, you'd say, okay, well then we'll just borrow at the 80, and then go get another 10%, 10,000. If you don't have the 10,000, go get it somewhere else at 15%, and that would obviously be cheaper than borrowing at the whole 90, because that extra 10,000, that incremental cost at the 90 here under this loan is almost 21%. Let's expand upon this problem. So the same problem, except now we'd say, well, what if we paid it early? So what if we paid it off after 5 years? Okay, what would be the results then? So we still have the same loan amounts, still 90 and 80,000, still at the same rates, still the same monthly payments. But now we need to find out what would the balance be on each of these loans after the 5 years. So you see those are calculated in the last column. So then the difference amount you'd have to pay back between them is the difference between the two loan balances, or in this case, $10,117.32. So now we need to put these in our calculator and say over the 5 years, having to take the payment of the 172 and then pay back the full 10,117, then what would be the effective cost? Now we see, once we put those in our calculator, again for 5 years, so n is 60, it's the extra incremental is a 10,000 as the present value, that would be a negative. The payment that you're going to make for those 5 years or 60 payments, 172.47, and then you have to pay back the rest of the loan, the balance, 10,117.32. Get that monthly rate, multiply it times 12, and you're going to get closer to 20.83%. Okay, so again, in this case, it's even more reason, if you're going to making this decision, that if you can't invest somewhere closer to 21 or borrow somewhere for less than 21, you have to decide what to do. You can't borrow for somewhere less than 21, then you'd have to borrow the full 90. But if you can borrow somewhere less than 21%, that extra 10,000, then just go with the 80 and borrow the 10,000 somewhere else if you have it. Okay, let's expand again on this problem. So same problem, but now we're talking about what if there's origination fees or points. So let's say on alternative 1, there's 2 points, and alternative 2, there's 3 points. So the net loan, again, was $90,000 for alternative 2, but there would be 3 points. So 3% of the $90,000 is $2,700, so you'd subtract that from the $90,000 because to see what the net amount that you would get from the bank, what would be dispersed to you, $87,300. In the case of alternative 1, it's $80,000, but 2 points, $1,600. So you'd end up netting or taking from the bank $78,400. Okay. So now instead of a difference amount of borrowing of $10,000, the difference in the amount of borrowing is $8,900, but the monthly payment part is still the same. So if we calculate the effective yield here with our calculator, assuming again that we're going to sell it after 5 years, and is 3. First we're doing it not after 5 years. First we hold it to maturity. So we have the next 25 years. So n is 300. The amount of money that we're actually borrowing, the extra amount, $8,900 in this case, once we take the points into account, $172.47 for the payment, fully amortizing, so your future value is 0. Calculate the interest rate, again, that's a monthly rate, multiply it times 12, and we see that it's 23.18%. Okay. Now, if it was over the 5 years, as I started earlier in the slide, then N would be 60, and the future value would be the loan balance that you calculated at the slide before, and you'd put that in as your future value. And if you calculate the interest rate there, you'd see it's almost 25%, 24.67. So you see there's very high incremental costs associated with borrowing extra money. Okay, let's look at the decision between borrowing one large loan or one loan plus a second. Okay, so this often comes up with if you're borrowing more than the $417,000 that's considered now a conventional loan versus anything over the 417, which is considered a jumbo. So generally it will cost you a little bit more for a jumbo versus a conventional. So you may decide rather than going for, and like for example in this case I said, so a $600,000 loan, say well instead of going for a $600,000 loan at a little bit of a higher rate, what if we could borrow $400,000, so at that conventional rate of, and that would give us at 6%, but then we still need the $600,000, so get a second for the other $200,000, and that's at 7.5% because the second, so it's riskier. They're second in line and so forth. So they have to pay a higher rate, 7.5%. So they're both for 30 years. So if we crank this out, we get the payment on the first loan, $2,398.02. That's the $400,000 at 6%. Then the payment on loan 2, $200,000 at 7.5%. Again, both loans for 30 years, fully amortizing, and we get a payment of $1,398.43. So we'd have to say, okay, now what then would this combined loan would be? In effect, we're borrowing $600,000 with a payment adding together the $2,398 and the $1,398. So we'd have a payment of $3,796.45. Okay, we'd be making that payment for 30 years, 360 months. Okay, fully amortizing, so the future value would be 0. So if we make that payment, borrow $600, make that payment for the 360 months, what would be the effective yield? And we see that works out to be 6.51. Okay, so if you could borrow a jumbo mortgage for $600,000 below 6.51, then you'd be better off just borrowing with a jumbo. But if the jumbos, again, the mortgages were over $400,000, so in this case, $600,000. If those jumbos were, say, 6.75, then you'd say, well, no, that would cost too much, so I won't take the jumbo. I'll borrow a conventional for $400 and a second for $200. Another kind of complication that's added in many of these problems is, what if you're looking at two different loans and there's different maturities? So, for example, in the last one, we were looking at a combination of loans where we had a first for $400,000 and a second for $200,000. Well, it could be possible. We said they were both 30 years. It's possible that the second might be shorter. So you might have a second that's only 15 years or 10 years. Okay. But when you're trying to find the complete effective rate, you have to find the incremental cash flows after all of the different periods. Okay, so if one was only, as I said, half the point, say for 20 years and the others for 30 years, well then for 10 years you only have one of the payments of the last 10 years. There's an example that does this on page 148, 147 and 148. So again, it's that same example that you have borrowing the extra $100,000, and then you say, let's say that because of the difference in the two loans, in this example there's $153 that's the incremental payment for 25 years, okay, 300 payments. And then in years 26 through 30, there aren't any payments from the second loan, so you only have the payments from the first, so the difference between them is just the one that's left, and that's $995.58. So to calculate the IRR here, you should put in the amount the extra that you're borrowing. So the cash flow times 0, going to the cash flow functions, clear out all your cash flows again. The cash flow times 0, the first cash flow would be the $10,000 extra you're borrowing. That would be a negative. Then the cash flow 1 would be the $153, and you would make 300 payments of those. Okay, so the frequency 1, the frequency for that first cash flow, is 300. Okay. Then the last 60 payments, the last 5 years, only one of the loans has a cost. So that would just be that second cash flow, $995.58. Again, the frequency is 60. And then you'd hit IRR and compute, and it would give you the return. So that's what you're doing mainly with the incremental cash flows, or any of the different cash flows. We have different maturities. You just need to take into account all of the different maturities. Or if you're combining two loans or ones, and you're trying to find the effective rate of the two loans combined, again, just add up all the different cash flows and take them into account when you're calculating the effective yield. Okay, now we look at the refinancing decision. Let's look at the steps. The first thing you need to do is find the payment and the current balance of the existing loan. Okay, so look at what your loan is right now. You probably already know your payment. You find out the current balance. And these book problems, they'll tell you borrowed $200,000 at 10% for 30 years. You can crank out the payment. Say it's 5 years old, and you can find the present value of all the remaining payments, and that would be the current balance. Okay. Then you'd have to find out what are all the costs that would be included to refinance. Okay, so there'd be origination fees and points and so forth. Add up all those costs. Then you'd find the payment of the new loan. That would be the amount of the current balance on the old loan. So if you found the old loan, so originally you borrowed $200,000, and now it's $175,000. So the new loan would be for the amount of the current balance, and then you'd say, well, what is it at the current rate? Okay, so whatever that current rate is, and crank out the payment. But in effect, you would not get that full balance because you would have to pay out the costs. So now we take the present value and say, what would be the balance of the loan currently, but subtract out the costs. Use the payment you calculated above in that third step, okay, for the remaining months that are left. So if it was 5 years old for a 30-year loan, it would be 25 years or 300 months, and you find the effective yield. Okay, and if that rate, that effective yield, is less than, it says here the current yield, but by the current yield I mean the yield that you currently have on your loan. Okay, so if you crank out that the rate you come up with is 5 3/4, and you currently have 6.5, then you obviously have a rate that's lower, and you should refinance. So let's look at an example. So if we go first and we figure out, say, okay, here's all the costs that would be involved in this refinance. There's a prepayment penalty. So if we refinance, we have to pay off the other mortgage, and there's a prepayment penalty, and they gave you what it is. Origination fees and recording fees. We add these up. See, the total cost that it would be to refinance is $4,105. Now, if the existing loan was an $80,000 loan at 15% for 30 years, we would calculate a payment based on that, fully amortizing, of $1,011.56. And let's say right now we're currently 5 years out. Okay, so it's a 30-year loan, but there's 25 years left. Okay. Now let's so when we use that, calculating that 5 years out, we would find the balance on that current loan. Okay. So, and it would be the remaining periods. If 5 have been paid, there's 300 left at that payment of $1,011.56, and you'd find the present value of those at the 15%. Okay, and so in this case, we'd do that, and we'd find out that the new loan is $78,976.50. Okay. Now, from that, we need to That is the balance of the existing loan, excuse me. From that, though, we now say, well, the new loans are at 14%, and again, we're going to just try to keep the term the same. So the other loan, the term was 30, but 5 years old, so there's really 25 years left. So let's say that the new loan we're going to look for would be a 25-year loan. So if we calculate that, we'd see that the difference between the monthly payments on this new loan and the monthly payments on the existing loan is $60.87 a month. Okay, so the refinancing decision, we subtract the total cost of the refinancing from the new loan and calculate the effective yield. And then if that effective cost is less than the old loan's yield, then we refinance. Okay. So for example, in this case, we have the 78,976, subtract out the 4,101, okay, and we put that in for our present value. N is 300, so it's a 30-year mortgage, but 5 years of it have already passed. We know the calculation was 9,950.69, and we know it says fully amortizing, and we compute the interest rate. Okay, and we get an interest rate of 14.86, which is less than the current loan of 15%. Okay, so calculate that out, and we find that the effective cost is less than the old loan's yield, and so we can refinance. Okay, in this case, we're going to talk about refinancing with no cash outlays. Okay, so here we're saying if we don't change anything, okay, if we don't put any other cash out, all we do is go to the bank and say, let's refinance. So if there's any cost, just add them to the balance of the bank, at the balance of my loan right now. And then you find out what your payment is. If the payment is less than what you're currently paying, okay, so it didn't cost you anything. Okay, it's same number of years, same loan amount. Okay, didn't borrow any more, didn't get any money back. And if the payment is less, then it would be a good thing to do. So in this case, we'd say we have again the balance of the loan at this point, 5 years in, 78,967. Add the 4,105 of costs. So the amount we'd be borrowing is $83,081.05 at the going rate, which is 14%, lower than the rate we already had currently of 15%. Again, we want to stay at 25 years because the original loan was 30 years, but 5 years have gone by, so we want to have the same amount of time left. So 25 years. We crank out the payment, and it's $1,000.10, which is less than what you're currently paying. Currently paying $1,011.56. So granted, it's only $11.46 less a month, but it didn't cost you a thing. Okay, right? You're still going to make the same number of payments, and the loan will be paid off. Okay, but now you're just going to pay out $11.46 less a month. So it has to be a better loan. But we could figure out what exactly the effective yield is to figure out, is it a better loan? So the payment, again, the $1,010, is going to be for 25 years, so N is 300, fully amortizing, so the future value is 0. And the amount that you're going to actually receive is the amount that you need to pay off the balance. Even though the loan is going to be for the $83,000, you only receive from the bank $78,976, which immediately you turn over to pay over the old loan. That's exactly what the balance is. And you compute the interest rate, multiply it times 12 because you get a monthly rate, and you see that it's 14.81%, which is less than what you currently have, the 15. Okay, so not a lot, only $11 as we saw a month, but it is better. Okay, so you might want to wait a little longer, see if you can get even a better return, but this wouldn't cost you anything. Okay, so here, we're continuing this decision on refinancing, but now I'd say, okay, same exact thing that we just talked about, same loan, going from a 15% to a 14% loan, staying with the remaining 25 years, but saying, you know what though, I'm not going to last 25 years. I expect to only have this loan for another 10 years. Okay, so the first thing you have to do is calculate the loan balance at the 10th year. And this is the loan balance of the new loan, because that's the one, if you refinance, you'd be paying off. So you've got the $1,000.10 payment for 15 more years would be left, right? Because it's a 25-year mortgage. 10 years go by, 15 years are left, so N is 180. And that new loan would be at 14%, so 14 divided by 12. But your interest rate fully amortizing, so future value would be 0, and compute the present value. And you'd see it's $97.16. Okay. So now we'd say, all right, what would be the effective rate if we paid this loan off, this balance, this $75,000 at the end of 10 years? Okay. So again, we're going to be making a payment of the $1,000.10 for the 10 years remaining. So 120 payments. The effect of the amount you actually receive from the bank, again, is the balance that you have to pay off. Not the $83,000, but the $78,976. And now the end, it's not 25 years out where the future value is 0. It's only 10 years out, so you have to pay the balance, which we calculated above, $75,097.16. And we compute the interest rate. Again, it's a monthly, so divide it by 12, and you get 14.98%. Okay, so it is just under 15%. So yeah, it's positive, but it isn't much of a motivation to change. Okay, another thing that we see so often is that sometimes the bank, when rates have increased, they would obviously like, instead of having that locked-in lower rate, they would like the borrower to pay back that loan and refinance at a higher amount. But how would they convince them to do this? Well, they could offer some kind of inducement to see if they would do it or not. So let's look at an example. Let's say there was an original loan for 15 years at 8%, and that loan was at $75,000. So the balance of that loan after 10 years, okay, is now $35,348. I'd say, all right, that's the balance right now. The payment on the loan, $716.74. But current rates are not 8%, but they're 12%. So I'd say, how could we get the borrower to pay back that balance of $35,000 and either reinvest or just pay it back to us so we can go out and invest it, because the current rates are 12%. Okay, we'll see what they offer right here is what about an lender inducement of $2,000. So what the bank is saying is, if you refinance or just pay back your loan right now, you don't have to pay $35,348. You can take $2,000 off of that. So you just have to pay us the $33,348. So the calculator solution here is saying, well, using this information, is this attractive to the buyer? Again, so this would be for the remaining 5 years. Instead of paying the $716.74, we just pay back the present value of $33,348. Then there'd be nothing left, so fully amortizing, and you compute the interest rate. It's 10.5%. Okay, this assumes now that the borrower has this $33,348 to pay back the bank. Okay, so if they have that money, they could say, all right, do I pay back the bank or do I invest it somewhere else? Well, if they can get more than 10.5% somewhere else, they should invest it somewhere else and stick with the loan they have. But if they can't find anywhere else to invest it for better than that, then they might as well pay back the bank, and at least that way they'll be getting 10.5% return on their money. Another issue that comes up often, and these are kind of all isolated, to a degree isolated issues, but we need to be able to deal with each one of them in real estate. So one of these here would be, this example here would be, what's the market value of a loan? Okay, so it's the amount that a new lender or investor would pay or be willing to pay, would pay to receive the remaining payments on the loan. So you got a loan that's left You've got so many payments. Okay, that's contractual. Say it's a fixed loan. There's this many payments coming back. And so you'd say, well, what are they worth to someone else? Well, someone else would take those and discount them back at their current return. Okay, so you're taking all the current payments due, and you're going to find the present value at that current rate to make a decision. Okay, so in this case, let's say it's an $80,000 loan with 10% interest, 20-year loan, 5 years out. Okay, and you already know the payments on this loan are $772.02. Okay, so the current loan balance, okay, there would be 15 years left, so 180 payments. Then the going rate we said was 10% divided by your 12. And we know the payment is $772.02. So we have a balance or a present value of $71,842. Okay. So now you'd say, well, what's the market value of this? Well, if someone else just took these payments, what would they get? Well, they'd get the payments that they would make of $772.02. But it'd be discounting these back at the going rate. Okay, which they're saying is 15%, so 15 divided by 12 is the interest rate. Okay, again, this is going to be fully amortizing, so it's going to go to 0, and N is 180. And we compute the present value. And we'd say to a new investor, these cash flows would only be worth $55,161. So as I said down here at the bottom, we could say that the mortgage is selling at a discount. Okay, take the current balance, $71,842, and subtract from that the market value. What's the current value, the market value of this loan? And that's $16,686, or 23% is a discount of the face value. Okay, now let's look at the effect of below market financing. So the effect of the difference of if you have to go get your own financing, or possibly there was an assumable loan, or some kind of a loan that's offered maybe like directly from the builder that is a below market value financing. So let's say that the market rate loan, the down payment would be $30,000, and you'd end up with a payment of $795.62. The assumed loan, the loan you could assume, would be $35,000. So you get crank out the payment there, $709.99, and then see what the difference between them is. So you would, on the assumption, you'd have the extra $5,000, but the payment difference is $85.63. So if we wanted then to calculate the effective yield here, say, well, in effect, we're borrowing or having to take out another $5,000, and the extra payment is $83.63, and there is 180 payments left, and the future value being 0. We compute the interest rate, and we see, get the monthly times 12, that the annual compounded monthly rate is 19.4. So now we looked at how much premium would you pay for this below market rate. Okay, so last time we just came up with a percentage rate and said, well, that's what it's worth, but say how much premium, because for that $5,000, we'd see the return was it about 19%, so it was a pretty good return on that extra $5,000 investment. But say if you could get a below market rate, so if someone who has a assumable loan, and you say it's below market, what value is it? So how much premium, how much extra could I charge on my house because of this below market rate? So if we look at the same example, but now we assume that the current rate is 11, okay? We know that, again, the payment, the difference between the assumable and the non-assumable for that amount is $85.63. We know there's going to be 180 payments of that, and then the loan would be fully amortized. And again, the current rate being 11%, so 11 divided by 2, and we compute the present value. And I'd say that assumable loan, that below market loan, is worth really $7,533.40. So you could pay up to that amount more. If it was a $100,000 house, you could really pay $107,533.40 more and be equal to a $100,000 house at the current rate. Okay, so that lower financing is worth, in this case, $7,500. Okay, let's look at wraparound loans. Wraparound loans are used to obtain additional financing while you keep your original loan in place. Okay, so you have an original loan for, we'll see the example that we're going to look at in a minute, for $90,000, but you want to borrow another $30,000. So you borrow $120,000. The bank from the bank, they maintain the $90,000, and so you get the difference of the $30,000. Okay, so let's look further at that. Okay, so let's look at some statistics. We've got an existing loan of $90,000, and the interest rate on that loan is 8%, and the remaining years left on that loan is 15 years. Okay, the current value of the home. Okay, so we've done a market analysis. The current value of the home is $15,000. So right now, your LTV, or loan to value, $90,000 is a loan to the value of $150,000. So $90,000 divided by the $150,000, the loan to value is 60%. Okay. If you wanted to borrow, again, most times people let you go up to 80% without charging a lot more, PMI and so forth. So let's say, well, we want to borrow some additional money. We want to go to the 80% rate. Okay, so then we'd go back and we'd figure out, well, if we borrowed $30,000, plus you'd have the 90, that'd be 120 divided by the 150. That would be an 80% loan. Okay, so you can do that and still avoid most costs as long as you have at least 80% in the home. And now you've got three choices. Okay, you could use the market rate of an existing loan. So just go out and get a new loan for $120,000 at 11.5%. Okay, so you get that new loan, you pay off the existing loan, $90,000, and you have the remaining money to move on. Okay. The other thing you could do is just take out a second mortgage for $30,000, and they're telling you that would be at about 15.5%. Okay, so take out the full amount and pay off the 90, being left with 30, or just borrow another 30. They're telling you the going rate there is 15.5%. The third choice is a wraparound loan. Okay, so you've got $120,000 that you borrow from the bank, in this case at 10% for 15 years, and you pay that, you calculate that payment, which we see here is $1,289.53. Okay, and then the bank takes that, but they still have to pay off the old loan, so they pay off the old loan, whose payment was $860.09, and you'll see that you then have a difference of $429.44. Okay. So now we've seen it, the difference that you would get in this case would be $429.44. Okay. So that's the payment. Okay, with this wraparound, that would be the difference the bank would receive. Okay, once they received the amount from you and then paid off the old loan, they would have $429.44 each month that would go to the bank. Okay, and that, if we want to find the effective yield on that, we'd say, well, we're going to pay that $429. We're only going to have a balance, the amount we're borrowing of $30,000. And that's going to be for the 15 remaining years, or $180,000. And we can compute the interest rate. And we see that it's 15.46, which, interesting enough, is approximately equal to the amount in the second, right? because we were saying people could go out and just borrow the $30,000 directly in a second. Well, we see that basically doing that is about equal to doing the wraparound. And we can also see what's the return. How'd they come up with that 10% return on the wraparound? You'll see the 90 divided by the 120 times the 8%, okay, which is some of the return that you would have on the original loan, and then the 30% at the $30,000 at the 15.46 that we just had calculated above, which gives us 9.865, or about 10%, which is what they said originally the wraparound loan would be. And one last issue is buy down. Okay, so we get it sometimes that the builder may buy down. Okay, so this may be a reason. One reason they may do it is to qualify a buyer. So say that these are small numbers, but that somebody wanted to borrow $75,000 for 30 years, and the going rate is 15%. Okay, and so we can't crank out the payment here, and then we'd say that the borrower can't qualify at that amount. But if the rate was only 13% instead of 15%, then you'd say, and we cranked out the payment, we'd see that it's $829.33. Okay, so if they could qualify at 13%, but not at the going rate, which is 15%, the difference between those is $118.68. Okay, so if we said, well, okay, if we can find out what's the present value of that $118.68, if we use the current return of 15%, and again, if they're going to just buy down the first 5 years. So the builder says, well, I'll just buy down the first 5 years. After that, you have to be on your own. A fully amortizing mortgage, and we compute the present value. And we see that comes up to be $4,988.67. Okay, so almost a full $5,000. Okay, and remember with this buy down, oftentimes what the builder will do is just say, yeah, we'll buy down, so you can get involved, but then they might just add that $5,000 to the value of the house. Okay, which would then again increase their payment somewhat, but not as high as just saying you have to pay the entire thing. Okay, so this is basically all of the slides for this particular chapter, and I will try to also do a presentation with particular problems.